Hello everyone. Today for this cantilever beam we are going to draw the shear force and bending moment diagrams. In this beam we have uniformly varying load. It varies from 12 kN per meter in the fixed end to 36 kN per meter in the free end. In the free end we have a concentrated moment 20 kN meter. It is acting in the clockwise direction. There is one more concentrated moment 10 kN meter. It is also acting in the clockwise direction at a distance of 2 meter from the free end. In the same point we have a concentrated load 40 kN. We can split the uniformly varying load into two parts. We need to draw a line like this. Above the line we have a triangle and below that line we have a rectangle. Using this rule we can find RA. RA is acting upwards, so it will be positive. The UVL is acting downwards, it will be negative. For the UVL we have to take the area. First let us take the rectangle. We know the area formula of a rectangle, that is length into width. Here the length is 4 meter and the width is 12. So this is the area. Now let us take the triangle. We know the area formula of a triangle, half into BH. Here the breadth is 4 and the height is 36 minus 12. So it will be 24. This point load is acting downwards, so it will be negative. For RA we will get 136 kN. To find MA from the point B, let us take moment about A. In this case we have to follow left hand side rule. The UVL is acting in the clockwise direction, so it will be negative. First let us take the triangular portion. We have to multiply the area of the triangle with the centroid distance. We just before found the area. We have to find the centroid distance. The centroid distance about the point A is 2 upon 3 into breadth. Here the breadth is 4. So 2 upon 3 into 4. Now let us take the rectangular portion. We know the area. We know that in the rectangle the centroid lies in the center. So the centroid will be the total length 4 upon 2. This point load is acting in the clockwise direction, so it will be negative, and the distance is 2. There are two concentrated movements. Both of them are acting in the clockwise direction, so both of them are negative. MA is acting in the anti-clockwise direction, so it will be positive. For MA, we will get 334 kN meter. Using the right hand side rule, we can find the shear force values at A and at C. Shear force at just left of A will be 0 and at just right of A will be RA, which is acting upwards, so it will be positive. In the point C, there is a point load, so we have to find the shear force 2 times at just left of C and then at just right of C. Let us find the shear force at just left of C. RA is acting upwards, so it will be positive. The UVL is acting downwards, so it will be negative. First let us take the rectangular portion. We know the area of this rectangle, 12 into 2. Then we have to take the triangular portion. We know the area formula of a triangle, half into BH. Here the breadth is 2. We need to find this height. For the distance of 4 meter, the height is 24. But we need the height at the distance of 2 meter. So we have to multiply with 2. In this way we will get the height as 12. This is the area of the triangle. For the shear force at just left of C, we will get this. Now let us find the shear force at just right of C. With this, we have to add this. This point load is acting downwards, so it will be negative. In this way, we will get 60 kN. Using the left hand side rule, we can find the shear force at B, which is 0. Here you can see the shear force diagram. To find the moments at A and at C, we can use right hand side rule. Movement at just left of A will be 0 and at just right of A will be MA, which is acting in the anti-clockwise direction, so it will be negative. In the point C, there is a concentrated movement, So we have to find the BM at just to left of C and then at just to right of C. Let us find BM at just to left of C. MA is acting in the anti-clockwise direction, so it will be negative. BA is acting in the clockwise direction, so it will be positive, and the distance is 2. The UVL is acting in the anti-clockwise direction, so it will be negative. For the UVL, we have to multiply the area with the centroid distance. First, let us take the rectangular portion. We know the area 12 into 2. We know that the centroid lies in the center. So to get the centroid, we have to divide the length by 2. Then let us take the triangle just before we have found the area. The centroid distance about this height is 1 upon 3 into the breadth. Here the breadth is 2. For the movement at just left of C, we will get this. Let us find the movement at just right of C. With this, we have to add this movement. This movement is acting in the clockwise direction, so it will be taken as positive. In this way, we will get minus 96. Using the left hand side rule, we can find the movements at B. Movement at just to right of B will be 0, and at just to left of B will be this movement, which is acting in the clockwise direction, so it will be negative. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.